Okay, welcome back. This is a section over graphing rational functions. So in the previous unit, we talked about vertical asymptotes. And what I want to talk about today is graphing these, and finding horizontal asymptotes of a rational function, and then, graphing these things. Okay, so anyway, let's just take a look at a rational function here where these two lines that are vertical, okay, are going to be your vertical asymptotes. Okay, so these are your vertical asymptotes. Okay, the horizontal line that you have here is your horizontal asymptote. Okay, and I'm going to talk about, we talked about vertical asymptotes. These are x values, okay, that make the denominator 0. X values that make the denominator 0. Okay, and then horizontal asymptotes, let's kind of talk about that. And a horizontal asymptote is a horizontal line, and I can remember horizontal by the word horizon. Okay, and the horizon line goes across like that. And as x goes to positive or negative infinity, okay, this is a line that the graph will not touch, that it will approach. Okay, so how to determine horizontal asymptotes? So finding your horizontal asymptotes isn't too bad. Okay, so what I want to do, we've got a couple different scenarios here. Okay, and we have to first look at the degree of the numerator and denominator. So look at the degree of the numerator and denominator, and that will tell you what your horizontal asymptote is, numerator slash denominator. Okay, and so here's what we do. The first scenario, so we have three scenarios. The first scenario is if the degree is small in my numerator divided by a degree that is big, okay, then we have a horizontal asymptote at the line y equals 0. Okay, this is the first one. Okay, the second option that we have is if the degree on the top is the same as the degree on the denominator. Okay, so if the degrees are the same, then the horizontal asymptote is the ratio of leading coefficients. Okay, and we'll look at a bunch of examples on how to get that. Okay, and then the third option, all right, the third option is if the degree is big up top and the degree is small down below, okay, then we have no vertical asymptote. We actually get a slant asymptote. All right. So we have three options, okay? This one is kind of my favorite. This one's the easiest one to kind of recognize. This one's a little bit trickier, okay? And so, let's just kind of look at, what we get over here. We had a horizontal asymptote at y equals 3, okay? So horizontal asymptote at y equals 3. So the example that I would have for this, okay, the example, because we don't get 0 here. The example would be, let's say you have a function like this. F of x is equal to, say, 3x cubed plus 2x plus 1 divided by x cubed plus, say, 3x, and I'll just leave it like that, okay? And let's just say that that's what we have, okay? Now, what I notice here is that the degree in my numerator is 3, okay? And the degree is the largest exponent, okay? And then the degree down here is also 3. So because these two are the same, all right, then we take the ratio of leading coefficients. Now, the coefficient in front of my x here is a 1. So what I do is I look at the 3 over 1, and this gives me my horizontal asymptote at the line y equals 3. And that's how we get that, okay? So something like that. That's just an example of how we get those. All right, let's take a look at the next page. Okay, on this next one, let's go ahead and take a look at this function here. F of x is equal to x minus 2 times 2x squared minus x minus 1. Now, I've gone ahead and just graphed it here, just so we kind of have a depiction of what the graph is going to look like. And let's go ahead and determine the horizontal asymptote of this graph. And so here's what I know. I know that my degree in my numerator is 1. Now, if there's no number here, I just know that value is 1. So the degree is 1 up top. The degree is 2 down below. So because this is small over big, okay, then my horizontal asymptote, is at the line y equals 0. Okay, and you can kind of tell over here that, over here as you approach, as x goes to infinity and negative infinity, we are approaching the line of 0. It won't, and I know that it's going to cross here, okay, at 2, but, and that's okay, but it's as x gets infinitely large and x gets infinitely small, what y value are we getting really, really close to, okay, and that would be 0 here and 0 here, okay. So let's go ahead and graph a rational function and kind of determine what we have here. Okay, so the first thing is first. Okay, what I'm going to do is let's find our horizontal asymptote. Okay, my degree up top is 2. My degree down below is also 2. So this is the same. Okay, now what I want to do is think about my leading coefficient. The number that's out in front here is a 1. Okay, so if there is no number, the number is there is 1. So what I want to do is take the ratio of leading coefficients, so 1 divided by 1. So my horizontal asymptote, okay, is at the line y equals 1 over 1, which is just y is equal to 1. Okay, so that's my horizontal asymptote. All right, and that's the first piece of information that we need. The next thing I want to figure out is my vertical asymptote, okay? And what I would do is I would set my denominator here, which is x squared minus 1, equal to 0, and solve for that, okay? Remember, we did this in the last video. I can factor this, and that's kind of usually the tactic, so let's go ahead and do that as x plus 1 times x minus 1, and that's equal to 0. So I get x is equal to negative 1, and I get that x equals positive 1, okay? And these are my vertical asymptotes, okay? These are my vertical asymptotes. All right, the next thing I want to find are my zeros, okay? And remember, this is where the graph crosses the x-axis, so where the graph crosses the x-axis, okay? And then what I've got, okay, so the zeros, what I want to do is you take your numerator, all right, which is x squared, all right, and you set that equal to 0. Now, the way to solve for that is you take the square root of both sides. You can take the square root of 0, and you get that x is equal to 0, okay? So that's the first thing I want to kind of calculate here, okay, and draw in my asymptotes and my zeros. So my 0 is at x equals 0, all right, so it's right there. All right, and that's where I'm going to plot the graph, okay? This is an x value, so, if I would have gotten another number around here, I would have just plotted that point somewhere along this x-axis. Okay, my horizontal asymptote is y equals 1, okay? And I'm going to label that here with this dotted line, okay? And then the next thing I'm going to do is label my vertical asymptotes at 1 and negative 1. Okay, so here's my vertical asymptote at 1, and here's my vertical asymptote at negative 1. Okay, so now what I want to do is kind of figure out, you know, how this is going to go. And what I usually like to do is just kind of plug in a few points. And so let's just quickly find like f of, say, I don't know, let's just plug in 2 and see what happens. So if I plug in 2, that's going to give me 2 squared over 2 squared minus 1. Well, this is going to give me 4 over 4 minus 1, which is going to give me 4/3. So at the point 2, okay, I have a y value of 4/3. So it's right about up here, okay? And then let's plug in, say, like a -2, okay? And let's see what happens. So here's my function. My function, we rewrite that as x squared over x squared minus 1. So if I plug in, say, like a -2, okay, then I'm going to get -2 quantity squared over -2 quantity squared minus 1. All right, and that's going to give me a value of, what do we got? What is that, 4 over 4 minus 1? So we get the same thing of 4/3. Okay, so I have a similar point over here of 4/3, okay? Now, what I think is going to happen is this. I think we're going to approach the graph like this, and we're going to come up like that. And again, we're going to come up like this. But what I want to do, let's plug in like -1/2 here, and let's plug in a half, and let's see what happens. If I plug in -1/2, okay, and for x, it's going to give me -1/2 squared over -1/2 squared minus 1. And so this is going to give me positive 1/4. So I get 1/4 over 1/4 minus 1. Okay, and so this is going to give me 1/4 divided by -3/4. Okay, and so then that's going to give me, what's that going to give me? What is that? 1/4 times -4/3. So what happens is I get a value of -1/3 out of this, and this y value down here is -1/3 if I plug in a half. All right, same thing if I plug in, say, a 1/2. Okay, I'm actually going to get the same thing here because anytime I square something, it's going to be positive. I'll get the same values here. So I get these points down here, all right, and then we come down here and just graph, all right, and that's what our graph is going to look like. Now, what I want to do actually is see what we get if we actually just plug it into the calculator. So let me plug it into Desmos and just verify that we do in fact get the same thing. Okay, and I've gone ahead and just done that, and you know, and all this comes down to is labeling. Okay, finding your vertical asymptotes, finding your horizontal asymptote, finding your zeros, and then testing some points that are in between those values to see where you would draw the graph. Okay, and just kind of know that you have to, you know, find those points inside those intervals. Okay, all right, let's go ahead and let's take a look at translations of rational functions. Okay, and so what we have here. X minus h, okay, this is going to be, so the h value, okay, so when you see this, all right, x minus h, that's going to be your horizontal shift, and remember that those are opposites, okay, opposite of what the sign says, and then the k, that's your vertical shift, okay? And all that's going to do is shift over your asymptotes, okay? So the horizontal shift is going to be your asymptote. Your vertical shift is going to be your, horizontal shift is going to shift over your vertical asymptote, sorry. Okay, and your horizontal shift is going to, or your vertical shift is going to do your horizontal asymptote. So it's a little bit weird. Okay, and remember what your parent function is. Okay, your parent function for a rational function is just f of x is equal to 1 over x. Okay, and that graph is going to look like this. All right. So that can just move it and shift it however you need to. Okay. So here, all right, if we think about that graph, all right, your horizontal shift, okay, this +1 here is going to shift left 1 unit. Okay. And then the -6 over here is going to shift shift down 6 units. Okay. And so what I would do then is I would say, okay, I'm going to shift this left 1 unit. So that's my vertical asymptote that is shifted left 1 unit. Okay. And then my horizontal shift, and this is 1, 2, 3, 4, 5, 6. It's going to go down here, and that's going to be my horizontal asymptote. Okay, which is a little bit weird to think about. So then when you graph this, your graph is just going to look like this. All right, and let me continue this down here, and our graph is going to look like so. Okay, and that's all we're doing. Okay, so I hope you enjoyed this video. I know it's kind of tricky. It's kind of weird. Always, refer back to Desmos when you're doing this so that you know what's going on. So I hope you enjoyed it. Talk to you later. See ya. Bye.